Hello and welcome. My name is Kendra, and I've had the delight of working with my incredible co-authors, Sandeep, Kollannur, Marian, Dörk, and Wesley, Willett, to create IOBITS, a user-driven, situated, and dedicated personal informatics system. So what does this mean, and why is it interesting? Traditional visualization research focuses on supporting domain experts with analytical tasks on desktop computers. Our research focuses on supporting regular people with daily tasks in their everyday environments. Many of the available self-tracking systems use similar approaches: automated data collection, integration into multi-purpose devices like smartwatches or mobile phones, and/or centralized information displays. While automated data collection approach reduces the burden on users, it also limits the type of data collected to phenomena that are easily detected. Automated data collection is often rigid, which can lead to a conflict between what the user cares about and what the system is capable of tracking. User-driven or manual data collection, on the other hand, allows the user to frame the question, decide what counts, and capture subjective and qualitative observations. Incorporating self-tracking tools into existing systems, such as mobile phones, can provide an inexpensive approach to collecting a wide range of data. However, this approach forces self-tracking tools to compete with other applications for attention. Logging also introduces a non-trivial amount of interaction overhead while engaged in an activity. A dedicated tracker with a distinct physical presence and location has the potential to remind people to log and facilitate faster interactions. Centralizing data consumptions on phones or computers allows people to access the data at will, often providing favorable conditions for complex interactions and deeper self-reflection. In contrast, distributing personal data into physical spaces where it is most relevant allows that information to be easily considered in the moments of decision-making. In response to the common tropes of self-tracking, we explored a novel approach to personal informatics, which examines how a user-driven, situated, and dedicated tool might support new kinds of self-tracking behavior with our prototype system, IOBITS. Some really interesting explorations of embedding personal data into a variety of environments has already occurred, including small e-paper displays that are capable of continuously and passively visualizing small bits of information they receive wirelessly, as well as situated self-tracking systems that invite more active participation from the user. For example, both the Everyday Calendar and the Citizen Dialogue kits both use button-based logging to facilitate simple and quick interactions. We wanted to explore the question, how do we ideate, design, and develop situated personal informatics systems to support people with their self-tracking process in new and useful ways? To start, we ran a series of design and ideation workshops to examine the design space. We varied the materials, locations, and prompts. Using these workshops, we considered what our self-tracking system should look like. 3 interesting clusters of designs required simple timestamps, counts, and binary toggles. For instance, a toggle to show if an office occupant is in, a timestamp to show when a jar of pickles was started, and 2 counts to track how many coffees were consumed from reusable versus paper cups. The data required by these examples could be collected using a plethora of sensors or simple button presses. This notion inspired our simple, user-driven, and generic data collection. With a better understanding of what our situated self-tracking system would look like, we ran our e-paper visualization workshop, which generated 40 designs. Analyzing the sketches, we clustered them based on recurring design elements and organized them to reflect emergent design dimensions. We have identified 5 clusters. The first cluster, text visualizations, which focus on displaying a single component of the data in plain text. Often this results in displaying counts, averages, or a single timestamp. Token visualizations added a new token for each button press. In our samples, the tokens were typically circles or squares and grouped into categories or placed along a timeline. Grid visualizations had an initial structure that was filled in based on the inputs. The initial structures were often grids, but some designs used an outline of a specific image, like a plant. Resizable shape visualizations use button presses to grow a variety of shapes. This included the traditional graph shapes like the bars of a bar chart, as well as less traditional forms such as the circles within a traffic light or speech bubbles. Visual ratio visualizations were described using words that emphasize the tension between 2 distinct parts. The pushing halves often consumed the whole display and were either uniform across the display to show a single aggregate ratio or had jagged edges to show how the ratio changed over time. In addition to examining the clusters, we examined the ways the visualizations differed, but for time's sake, we won't go over those. Using our workshops as inspiration, we designed and built several generations of prototypes. Our prototype system combined a simple, user-driven data collection process with a set of visualizations and a self-contained and dedicated hardware unit. These small battery-operated devices can be situated in a wide variety of locations and support many tracking tasks. Each IO-bit includes a low-power Wi-Fi-enabled microcontroller, a rechargeable battery, and an e-paper display. Users can log data using 2 input buttons on the face of their device that produce timestamped logs on a local server. The 3 buttons on the top act as system controls to undo, create a new file, and switch between visualizations. The combination of a large battery with a low-power display and microcontroller results in a battery life that lasts at least 3 weeks under typical use. We implemented a set of 5 visualizations that the user can switch between to see different aspects of their data. As you can see, 4 of the 5 visualizations we implemented closely follow from the design clusters we saw during the e-paper visualization workshop, with a notable exception being the streak visualization. This was inspired by a discussion where our participant was trying to design a less judgmental daily habit tracker. Once we had a prototype version we were happy with, we examined the impact IO-bits made on participants' self-tracking. We decided to do so via a small-scale deployment of our system. We had 6 participants build and use IO-bits for a period ranging from 4 days to 3 weeks. 1 participant tracked their work-life balance, 2 tracked their daily routines, and 3 tracked aspects of their hobbies. All the participants placed the IO-bits on a desk, nightstand, or table, and 5 of the 6 participants used the counts or ratio visualization. Using the deployment, workshops, and our own experience, we derived a set of 4 insights and observations, as well as a set of 4 questions to guide future research on the topic. I would like to highlight 2 of each for you. Simple generic tracker designs can support a wide range of different tracking tasks while also providing a sense of privacy and allowing the data to expire when no longer relevant. Every one of our participants across both the e-paper visualization workshop and our prototype deployment proposed unique ideas for how to use their IO-bits. The wide range of proposed uses suggests that these kinds of general-purpose trackers with task-agnostic interfaces could indeed enable a diverse set of untapped uses for personal informatics. Simple, flexible personal informatics tools can make it easier for users to pose new questions and explore more diverse and personal tracking topics. The tracking topics participants proposed during our workshops were not only unique, but they also tended to reflect the particular goals, interests, and personalities. Some participants emphasized the way in which personalized trackers could help them align with their own identity and ambitions rather than externally imposed ones. Our preliminary results suggest the presence of a much more diverse list of highly individualized personal informatics use cases that are not readily serviced by current tools. As such, we see clear opportunities for minimal, multi-purpose tracking tools to facilitate more personal, casual, and idiosyncratic tracking topics. What input mechanisms best support low-burden, nuanced, and flexible data collection in situ? Reconciling the desire for simplicity with expressive power remains a persistent challenge in interface design, and is particularly salient for tracking tools which are intended to integrate into everyday life. In our IO-bits deployment, participants' feelings about the simplicity of the tracker fell into 3 categories. 2 enjoyed the simplicity of the device, noting that its constraints prompted them to more carefully consider their priorities. 2 were more ambivalent about the benefits of the device's simplicity, but were still able to capture something they had previously been interested in tracking. And the last 2 found the device limiting and wished it was capable of tracking more nuanced aspects of their lives. What strategies can be implemented to maintain privacy and visibility when displaying personal data in situ? Trackers with always-on glanceable displays accentuate issues of privacy and visibility that emerge frequently in personal visualization literature. In our deployment, participants regularly speculated about how visitors in their home might interact with IO-bits and suggested several strategies to maintain privacy from visitors. This included placing the trackers in drawers, lightweight triggers for toggling visibility on or off, or using more artistic, abstract visualizations that are difficult for others to decode and not obvious data representations. So to wrap up, with this contribution, we explored the viability of an alternative approach to self-tracking. We aim to develop simple tools that empower people to pose and answer data-driven questions about themselves. While IO-bits are a straightforward technical device, they run contrary to many self-tracking tropes. Dedicated, situated, and user-driven trackers can bring focus to personal tracking tasks and provide unique opportunities to prompt reflection while engaged in those tasks. Our work shows the promise of these types of tracking devices and highlights opportunity for future research. Thank you for listening.